Hallelujah.
Welcome now to our platform. This is called the Science Theater. It is found in Uganda. Yeah, we are glad to be having you in large numbers. Those following us online, you're most welcome. Today we are going to talk about the Science Theater has brought something called COVID brought issues. Okay, the Science Theater has brought something called projectiles. We are going to talk about projectiles. Majorly, we are going to first define the terminologies in the projectiles and mathematically, not just English. We are going to define them, and thereafter we shall learn more in other videos. Today we are going to define projectiles. Those guys in university levels in Uganda and abroad, yeah, this is just projectiles. They are being utilized in the current affairs which are happening in Europe. Yeah, those wars. They use projectiles. You know that if I project this, it will go to a city called this. Right? That's none of my business. But I start with projectiles today. We're going to learn about projectiles. Projectiles. Yeah. What is a projectile? A projectile is any particle that when you give it an initial velocity, yes, it will move under influence of its weight only. For instance, it moves under its velocity only. If I try to consider, let's change the marker. Consider this particle. I'm going to project a particle, move from point A, yes, to a certain point B, whereby these 2 points are on the same horizontal level, like that. Yes, this particle is moving from here to land at point B. So I put my point B here. Yeah. As I project this particle, I assume I have given it an initial velocity, u meters per second. That is the initial velocity. This particle will travel from point A to point B, which is on the same horizontal level. I consider that, but it can go below, or it can stay up there. If you put a force to oppose it, but I said it will move under influence of its own weight, yeah? So this particle, I have projected it at an angle, let's say an angle beta. This angle beta means is the angle of projection of my particle. So this particle, as it moves, it will encounter a certain height. This height here is noted because it is called the maximum height, which the particle reaches, and then it changes to go back to the level of projection horizontally. So this particle, as I'm projecting it, that is all. So if I try to put my axis here, yeah, this is the vertical axis, this is the horizontal axis. So it moves with the initial velocity u meters per second to land at point B in the same horizontal plane as A at any time t. At any time t. I assume my particle let me assume it is at point K. When it is at point K, it has a vertical displacement. I can call it y. It's the vertical displacement of the particle. And its horizontal displacement, let me call it x. X is the horizontal displacement of my particle. Yes? At point K. This point K has occurred at a given time, which we said at like time called t, small t. So these are all All these are terminologies. I'm going to define them mathematically. That's why I'm here today. If you just follow me, you will enjoy. Yes. If I start by defining the horizontal displacement at any time t, it means the horizontal displacement, yes, you can call it x, will be equal to, normally we say that distance is equal to speed times time. Yeah. Now, according to my speed, it is inclined at a certain angle. So if I consider the horizontal speed, it means this will, I will get the u sine beta here, sine beta, and I will get the u cos beta here. So it means the horizontal velocity was u cos of beta times the time t. Yeah? That is how we do it. It is u cos beta times time t. That is the horizontal displacement at any time t. And the velocity of the particle at that point, the velocity of the particle, horizontal velocity, is obtained by just differentiating. It is dx dt, which will be, in respect to t, I will get u cos beta. That is the horizontal velocity. And that one does not change. This one, it does not change. It is the same throughout the whole projection. Yeah. If I get the vertical displacement, call it y. This is defined by the vertical velocity u sine beta times time minus a half gt squared. Yeah, something like that. And the vertical velocity at that time is given by just differentiating dy dt, which we can call u sine beta minus dt. If you differentiate, yeah, that one you know differentiation. So u sine beta minus dt. Yeah, that is the vertical displacement. So there we have two terminologies. We've got therefore, moreover, four, the velocity, the horizontal velocity, the vertical velocity, and now I want to go to another terminology. The third terminology, I'm going to call it look here. Let's call it time of flight. Time of flight. The time it takes to fly. Yes, it's the time taken for the particle to travel from point A to point B. I denote it by capital T. Yeah, that is the time it takes to travel from point A to point B. That time of flight, I will define it like look here. At this point B, the vertical displacement is 0 because it has come back to the horizontal level. So the vertical displacement is 0. Yes? Though the horizontal displacement, we shall call it capital R, which usually defines the maximum horizontal distance covered by the particle to come back to the same horizontal level. It is that, in fact, yeah, that is it. So that is capital R. So we said at B, if I consider at B, yes, using this as U, yeah, U sine beta t. So this one has changed to a 0 minus a half g t squared. Yes. It means if I make t the subject, my t into u sine beta minus a half gt is equal to 0. means that every time used is either 0 or t is equal to, yes, so what do you get? 2u sine beta over g. 2u sine beta divided by the gravity. Yes. I see? Okay, good. So this is the time it takes this one. It can't be 0 because I projected this t0 means this point. So the t equals 2u sine beta over g is the time it takes to travel from point A to point B. Because it is at the same horizontal level. That is the third terminology. Now our fourth terminology, allow me call it the horizontal distance, capital R. How do we get it? Capital, I said which? Where is the marker? Okay, thank you. Yes, this capital R is the maximum distance covered by the particle to cover this distance AB. Yeah? And it will be given by, it is a distance. So it will be given by velocity, horizontal velocity, times capital time t. It means this will be horizontal velocity was u cos beta times time taken has been 2u sine beta over g. Therefore, we shall be having 2u, we shall be having, you go to the trigonometry, u squared sine 2 beta over g. And this is our maximum distance, r. We said r is the distance covered from A to point B. X was just a horizontal displacement of the particle at any time t. You get it? Okay. If I'm to talk more about that capital R, the capital R means that it can be maximum, that R can be maximum if sine 2 beta is 1. Yes? It can be maximum if the sine of the sine 2 beta is 1. Which will mean the beta will be 45 degrees. The 45 degrees means that it is the minimum angle. That to get R, at least you must have 45 degrees of projection. So this is the minimum angle. Beta is equal to 45 degrees. I got it from saying that maximum R occurs if sine 2 beta is 1. And beta was the angle of projection of our particle. We're going to the 50th terminology. Allow me to rub off somewhere. Like here. Yes. Let me rub off here. I hope you have been following. You will enjoy the mathematics. It's not hard. Yeah. Our next terminology, we shall call it the trajectory equation. I mean maximum height. What is maximum height? We talked about maximum height here. It is denoted by h max. But what is special about h max? That as the particle is projected upwards, it reaches a point where it has to turn back to the ground. Meaning, it will have a velocity which is 0 vertically. So it means that maximum height, our vertical velocity is 0. You get it? If you don't get it, forget about it. But you don't need to forget about it. H max is obtained if at that point where the velocity vertically is 0. It means from this equation which says that y is equal to u sine beta. No. we defined something previously using the velocity, this one. This one, the Vy was u sine beta minus dt, which is 0. It means the time it takes to reach that maximum height is u sine beta over g. And if you look at this closely, it means this is half of the time it takes. Yes, it is a half of the time it takes to cover the whole distance A to B. You get it? Yeah. Then that is the time it takes to reach the maximum height. Now, if I need the maximum height as it is, I use this other equation. Let me try to rub off here. Yes. The max. Now I want to obtain the H max, the maximum velocity of the projection of the projectile. H max, we've said we've got the time taken to reach H max, and we have got the velocity, vertical velocity, which is 0. So if we use this equation that a square of vertical velocity minus 2gs, yeah, it means the vertical velocity is 0. Initial, this is supposed to be said, yeah, this is supposed to be, the initial is here, which was u sine beta squared minus 2g, yes, 2g times h max, yeah. It means my h max will be denoted by u squared sine squared beta, yes, over 2g. Yeah, that is the maximum height of the projectile. Yeah. Now, the last terminology we can talk about is the trajectory equation. This one I'm going to write it here such that you can be in class. Are we at par? I hope so. Those online, yeah, we are still at par, I hope. Yeah, you will be blessed. These things are simple. You must pass exams, you must pass simple things. You just learn the projectiles. I'm getting things from head, your head can as well. Yeah, math is not hard, just to learn these things. You calculate, you formulate your new ideas, you share out them, you mark you get marks. And you pass, and you go to other levels. You apply your mathematics, you create bombs, you create missiles. You see a lot happening outside there which has mathematics. You'll enjoy it. Let me rub off and we continue. Yeah, I'm going to write it here. And that is the projection, the trajectory. What do we call a trajectory? This one here is the trajectory. And it represents the path taken by the particle. It is an equation of the path taken by the particle to reach B as it was traveling through air from point A. And this one I will say that consider particle at point K. I will get a particle and assume it is at point A. When it is at point A, it means at point K, it is point K, sorry. It means my x, recall we got the x, this K has coordinates x and y. But we said that x was u cos beta t. Yes? And we said that that is it. So it means the time at that point K will be defined by x over u cos of beta. To get the equation, I will apply this y, which is u sine beta, times 2, which I've got here, x over u cos beta, minus a half g, that is still x over u cos beta, squared. Yeah? Now the rest is mathematics, and you will express these things in the way you want. For instance, for me, if I try to calculate, this is a term somewhere there, and it will be x tan beta. That is y minus, if you see that, it's the same as having g x squared. First squared weight is under, it becomes sec up, sec squared beta over 2g. Sorry. The g is up over 2u squared. This can further be expressed in terms of tan, and our answer will finally be that the trajectory angle, trajectory, is x tan beta minus gx squared 1 plus tan squared beta over 2u squared. Yeah, those are the terminologies we need. Those are the terminologies we want. Thanks for following. We love you. Yeah, that is the trajectory angle. If you can level it. Yes, thank you.